All right, welcome everybody. We're gonna get started a little bit early. Just a couple of administrative notes before we get started. First, if you could just silence your phones out of respect for the speakers. The session's also being recorded, so you don't want your awesome ringtone to show up in the video. Fire exits are out and to the right, restrooms are out to the left, and then at the end of the session, there will be a survey in the app. If you guys could please fill that out, that'd be great. Without further ado, your first speaker, Kumar.
Hi everyone, my name is Kumar Venkateswar. I'm a principal product manager in the AWS machine learning team. And the product that I primarily focus on is called Amazon SageMaker, which is a machine learning platform product intended to accelerate your machine learning lifecycle. So I like to usually start out with a little bit of context as to why machine learning is important. Because sometimes you think about the heavy lift that's involved in getting machine learning and setting up an infrastructure for machine learning. And you think, why is it really important for us to use machine learning? Are there alternative technologies that we can use in order to accomplish the same kinds of things that we would be able to do with machine learning? And if you look at the numbers around data, machine learning is centered primarily around data. And the growth in data that we've seen over the last decade or so, we've seen 1,000% growth in data every 2 years, as in 90% of all data has been produced in the last 2 years. And if you compare that to the population growth of 1.5% per year, roughly, or 1.5% in the last 2 years even, it's not nearly enough to keep pace with the level of data growth, which means that the only way to be able to use this data effectively, you can't hire additional people in order to work with data. You have to be able to apply some technology in order to adequately use that data. So the result has been that most of this data has been untapped. And there's no way for us to grow our workforce fast enough to keep up with this data growth. So machine learning, the way I see it, is the solution to this problem in a way. It's the technology that enables you to take human expertise, distill it, learn it in a scalable way, and apply it so that you can actually get something useful out of this enormous volume of data. So the first thing I like to think about is, what do I need to do in order to be successful with machine learning? You have to start out with the right question. And sometimes there are subtleties with the kinds of questions that you ask with machine learning. You think, I've actually had some C-level officers come to me and say, I'd like machine learning to be a solution for how I can lead my business. And while that's nice, it's not a precise enough question that we would be able to answer it with machine learning, collect the data that we need, figure out the right algorithm, and figure out how to apply that knowledge. It has to be something much more scoped and precise. So not, how will the weather be tomorrow? It's more, what will the high temperature be tomorrow, in a very scoped kind of way. You also want to be able to say, ask additional questions that help you get to that. So you can get guidance on how to run your business or how to run your agency or organization through that. But at the same time, you have to figure out the right set of questions that you need to ask in order to get that answer. The kinds of questions, will it rain tomorrow? Will it rain tomorrow? Was it unusually hot? What is the chance it'll rain? These types of questions are the kinds of questions where you can take data, you can collect data, you can use that historical data in order to develop a model, and then make predictions about the way things were. And if you look at these questions, you have to make sure that you're actually asking the right question. If the question is, what should I wear tomorrow? And you're asking, what will the weather be? Well, you're going to be in here. So if you're going to be in here, what does it matter? You need to know what the temperature is in here, not the temperature outside. So you have to make sure that as you're preparing to do this, that you're asking the right questions in order to make it actionable for the thing that you really want to know. Not just that, but you want the right data and the right compute so that you can apply machine learning to that problem. And an example that I've heard a lot of over the past few days is the example of object recognition in ImageNet. It's a pretty common example. It's something that has data that's very easily available. There's a lot of research in the area, and it's widely usable in a lot of different situations. On the other hand, if you say, I'm going to develop a model, an object detection model with ImageNet, and then I'm going to apply it to overhead images, that doesn't work. You're not able to use that same kind of thing because it wasn't trained with overhead data. One of the customers that I've talked to actually has the opposite problem, which is they have a robotic cleaning device that runs on the floor, and the view that that robotic cleaning device has of the world is from the bottom up, which means that it also can't use the ImageNet data set. You also can't train that with the ImageNet data set because a chair doesn't look the same when you're looking at it from 2 inches off the ground. So it's important to have the right data for that question that you're trying to answer. The other thing it's important to have is the right compute. So for the large volumes of data that you would have in these image cases, you probably want a GPU. And you want to be able to apply a large number of GPUs to these problems, depending on the size of your data set. Certainly, if you're doing, if you're learning on a big data set like ImageNet or SpaceNet, you want a very, very large body of compute to be able to apply to it. On the other hand, if you're doing something like gradient boosted trees using XGBoost or something like that, you would want very powerful CPUs. And looking at tabular data and XGBoost, you'd want CPUs like Intel CPUs in order to apply to that. The other thing that you want to make sure that you're able to do is you want to have lots of iteration through this entire process. It's not a single shot process. It's something that takes a considerable amount of iteration, and it takes experimentation to get correct. So one of the challenges with that is not only computational and technology related, but the challenge with that is if you have a situation where your organization expects the results to be perfect the first time out, that's usually not going to be the case with machine learning. You want to be able to have the freedom to iterate on it, deploy things in a way that is controlled, be able to learn from the things that are deployed, collect data that helps you inform your next iteration better, and so on and so on. The value of applying machine learning to these problems is not just that you're able to get good results initially, but it's the fact that you can continue to collect data and continue to get better and better over time. And it's the fact that you get better over time that's the real value in machine learning. In other words, moving fast and steadily is the thing that wins. So just like software development is iterative, you want to be able to lean forward and push things out and to be able to understand what's going on and then iterate and iterate and iterate until you get it to the point where it's a great experience. You want to do the same thing with machine learning. It also, because it feeds on data, you want to be able to push it out, understand what data that you need to collect, and then go back and iterate on that and make sure that you're able to take advantage of the data that you're collecting. So what's the result of that? The result of that is that you want to make sure that you're making decisions in such a way that they're flexible enough that you're able to iterate, and you're not deciding on every iteration, hey, for this iteration, I want TensorFlow, therefore I want this infrastructure, and I have to build this infrastructure around it. And hey, for this other iteration, I need PyTorch, and I need to build this other iteration or this other infrastructure around it. The important thing is to distill out the things that are common between the iterations and between the variations that you're likely to have between experiments and between projects. And that way you can focus on the things that are unique to a particular iteration or a particular project, because that's where you want to focus your efforts, and that's how you get quicker at iterating. So how can Amazon SageMaker help you with this process? Our goal at AWS is to put machine learning in the hands of every developer. And part of the reason for that is because of this iterative process. You also, for this iterative process, you need to be able to have as many people who are able to do machine learning as possible. You want to conserve those expert data science resources, those expert machine learning engineers for the truly hard problems that are intractable except by a machine learning engineer. And you want to enable all of your developers to be as productive as possible using machine learning. That's one of the challenges with machine learning is that you want to be able to democratize it as much as possible in order to move faster. So what was the thing, as we stepped back and we looked at that problem, one of the things that we decided in AWS is we need to build an infrastructure that allows data scientists to be data scientists. Focus on the data science and machine learning parts of the problem and not worry about the infrastructure. While at the same time, we wanted to be able to enable developers to take advantage of some of these data science technologies in a way that they would be able to understand and they would be able to utilize them for some of the problems that the data scientists wouldn't necessarily be able to get to quickly. And the third thing is be able to transition between one audience to the other. So if a developer takes a shot at a problem and says, I'm going to look at this fraud detection type of problem. I'm going to try and find this particular type of fraud. And I'm going to develop a model around it. Maybe I'll use XGBoost because it's convenient and I know how to use it. And I have this tabular data set. I'm going to apply it and try and figure it out. And suppose they come up with a result that doesn't meet business goals. Then you need to be able to say, OK, fine, we'll take that project and then transfer it over to a data scientist, and they would be able to use the previous iterations in order to be able to take it over the finish line and complete the mission. What we found was that machine learning was too complicated for everyday developers. There's so many barriers through the entire process. It's everything from collecting training data from everywhere, and we actually had one of the things that we did in SageMaker in order to make this process easier was we developed a way that you could do active learning. So you could label the data and have automated labeling of that data, and the machine learning model would learn how to label that data as it went along. And the reason we did that is because it's very challenging to collect and prepare training data for machine learning. The second thing we did was we looked at choosing and optimizing machine learning. It's one of the challenges that we saw that people were having in the space. Developers would come in and they wouldn't know necessarily which algorithm to use and how to decide between them. It was difficult for both data scientists and developers, particularly in spaces that needed high security, to create these environments in which to build and train these models. Because of the security requirements, we saw customers were ending up in this situation where every project needed to be approved by security, which doesn't lend itself to that easy, quick iteration that I had talked about earlier. And then, of course, once you get to training and tuning, it's not only difficult to do or to develop distributed training algorithms that you would need for this large volume of data, but it's also difficult to use things like Bayesian hyperparameter optimization, which enable you to tune that model to meet your objectives. And that's something that you can throw compute at the problem and you can do things like grid search, but it ends up being expensive and hard and something that you wouldn't be able to do on a regular basis. And then, of course, the last part is once you have this model, you want to be able to take it and deploy it into production wherever you want it to be in order to get business value out of it. Because at the end of it, that's where you get the business value. Once the model is deployed, and once it's in production, and once it's actually doing things in that production environment. And in that production environment, you want to be able to monitor and manage it, and you want to see which version is deployed, and you want to be able to deploy multiple versions and do blue-green deployments in order to make sure that your infrastructure still remains up in spite of the fact that you're pushing new versions every so often. You want to be able to say, this model is meeting our latency goals this model or this solution has been up and maintains our availability goes and so on. There are a lot of operational challenges. And when you get to the right side of this flow, you get into a realm where data scientists didn't feel very comfortable either. So not only was it too complicated for everyday developers, it was too complicated for everyday data scientists as well, and they didn't feel like they had enough ownership of the end solution, which meant that overall this was taking customers 6 to 18 months per iteration, which is just way, way too long. So what did we do? We said, let's break that down, and let's break it down into manageable pieces, and let's develop capabilities that we can offer to our customers around each of these things. So we started out with this notion of there's a build environment in which you're able to explore the data, understand what the data is, and to be able to plan out the machine learning process. Then we said there's a training environment in which you can take that data, perform distributed training, and to be able to understand that. One of the challenges that we had in the distributed training space is that everyone has their own favorite algorithm, and everyone has expertise in an area. This is one of the things that we realized pretty early on, is that Amazon is great at machine learning. It's something that we've been doing for decades, but every time I talk to a customer, every time I come to a conference like this, I learn new things. I learn more about how people do machine learning. So we couldn't say, hey, you know what, I have the solution for you. We can't do that because there are experts in this audience that know more about their particular domain, way more than I do. Which means that we needed a way that we had this training environment that we could take your expertise and to be able to plug it into the SageMaker infrastructure in order to make it so that you can take the things that are unique to a particular project and only focus on those. And then lastly, we had to create this integrated deployment environment with managed inference clusters in order to accommodate both batch and real-time applications. So in this particular space, I think there are particular aspects of this that are of higher value than maybe in some other spaces, and I thought I would take a little bit of time to talk about those particular aspects of things. The first one is the set of security features. A lot of this audience has unique security requirements. I know you guys treat security very, very seriously. The risk of data leakage or anything like that is very high, and you're very concerned about it. So one of the things that we did was we said, SageMaker will be security first. We will make sure that the environment that data is handled in is up to the standards of the highest security that we can think of, that we can get feedback from customers on, and we will make sure it adheres to those specifications. So we looked at things like virtual private clouds, which AWS offers, and integrated with that, we looked at Private Link, which allows you to train and deploy models without any of the data going over the internet at all. Of course, there are things like encryption at rest, encryption at transit. We're, of course, also looking at things like homomorphic encryption and differential privacy in this environment in order to keep pushing the security boundary. And the goal here is provide an environment that allows customers to take this environment and use it for all of their data, not just the unclassed data or the lowest security level type of data. We want it to be suitable for use with all of the data that you have. So what kind of thing does this look like? I'm putting code up here. We don't necessarily need to go deeply into the code. But the idea here is that you would be able to, within this environment, provide specific parameters that allow you to say it should be in this particular subnet, it should be encrypted, it should be very easy to incorporate in the security features for any particular project that needs it. The second thing we did was we said it has to be modular. Everyone has their own solution that they like. We even had customers in the commercial space talk about how they loved their Spark environment. They just wanted some way to deploy it. So what we said was we really want to make it so that it's modular, so that you can use what you need and supplement your overall machine learning flow so that you go faster through the entire process. Because again, that's the goal, faster iteration. So you can supplement what you have and what you like with the things that you don't have in order to make it possible to go through this entire flow really quickly. And the result of that is that all of these components are addressable through APIs. When it comes to creating the notebook environment that you use in order to analyze the data, you have a single API call that produces back a URL that you can use, and you can use that pre-signed URL in any portal that you have. It can basically integrate together with your application in a way that end users don't even know that behind it is SageMaker. And the same is true with both training and deployment, whether it's real-time deployment or batch deployment. All of the components that we have in SageMaker are driven by these APIs. The next thing that's interesting is that because we designed this in a modular fashion, we also had a way that we could produce things like optimizing and deploying the hardware. So we ended up having customers like GE Healthcare who were very interested in using SageMaker for their critical data. They had critical healthcare data, they had X-ray images, MRI images, and so on. And they wanted to be able to use machine learning for those problems for similar reasons that I described with the deluge of data. Because you can have so much data coming in, but at the end of the day, you can't have radiologists look at all of it. Sometimes you end up with an intern that's been on call for 36 hours straight and can barely keep their eyes open as they're looking at the X-ray. So what do we want to be able to do? We want to be able to take that model, put it onto an X-ray machine, have the X-ray machine highlight areas of interest, or provide ways that you can aid that poor intern. And that means that that can't be necessarily in SageMaker. It has to be something that can be deployed to an X-ray machine, because not all those X-ray machines are connected to the cloud. Sometimes, some of you have told me about situations where you have things in the field and you have devices in the field that you have to deploy to. So I wanted to make sure that we were designing SageMaker in a way that was compatible with that, so you could train in the cloud, train in SageMaker, and deploy to the device so that your inferences are close to where your data is. So what does that look like? You can create this compilation job that optimizes for a particular hardware target. In this particular case, it's a Raspberry Pi. You can optimize it for that Raspberry Pi, take those model files, and you can deploy it. And that's true of everything that we train within SageMaker. You can take those, you can take that data file, those data files live in your account, and then you can take that and deploy to whatever target you want, whether it's SageMaker or not SageMaker. The next thing that we did was we wanted to make sure that we provided an array of choices. So for developers, they don't know how to choose algorithms, and having them develop these algorithms from scratch was pretty daunting. So what we said was, we'll provide a set of examples, and we'll take those examples and we'll also develop the algorithms, the most common algorithms that people use in the space, and we'll develop those. So we have a choice of 18 different built-in algorithms within SageMaker. But for the experts, we also support open source, various open source frameworks, including TensorFlow, PyTorch, MXNet, Chainer, XGBoost, scikit-learn, and we continue to add to that as we get feedback from customers. So not only can you use the built-in algorithms in cases where they're suitable and work well, but you can also develop your own algorithms on top of these open source frameworks, and you can bring them in to SageMaker in order to take advantage of the rest of the infrastructure. So what does that look like? Essentially, we have this list of different built-in algorithms that you can use, starting from things like linear learners, clustering of various kinds, k-means, KNN, and things like dimensionality reduction like PCA, and so on, which means that you have the flexibility to be able to use this for all of your applications. So next, I'd like to hand it over to Balaji to talk about who does machine learning well.
Thank you, Kumar. This is the last session of the day, so thanks for bearing with us and patiently listening. Let's talk about some customers who are using SageMaker today. Intuit is one of our forward-leaning customers when it comes to using SageMaker. They use SageMaker for expense finder, which automatically pulls a year's worth of bank transactions and find what are the expenses that can be deductible as part of the taxes every year that you file. And they were able to identify on an average over $4,300 in business expenses. NFL has over 180 million fans worldwide. About 17 million of those fans, they go to the stadiums for each season, which means 90% of the fans, like me, watch the games at home. A lot of times on mute because I have 2 little children and they're probably sleeping and I can't have the TV loud. So what they do is they use SageMaker to ingest the 3 terabytes of data that they collect every week, and use SageMaker to not only improve the fan experience, but also predict route a player is going to run. So they overlay that on top of the game feed, so that way it provides a real interactive experience for fans. Propeller Health's mission is to improve people's health with a digital medicine platform that helps patients manage diseases by delivering concrete insights on symptoms, triggers, and medications that they use. They use SageMaker to build and deploy these personalized disease models and essentially giving patients new ways to kind of ingest and also provide symptoms and triggers and medications that they could use. Advanced Microgrid Solution is an energy services platform that aims to accelerate worldwide transformation to a clean energy economy by facilitating the deployment and optimization of clean energy. So they use SageMaker. So essentially, they're using TensorFlow on SageMaker. One of the things that Kumar touched base on, we have first-class support for TensorFlow and AWS. As a matter of fact, over 85% of the TensorFlow that is running on the cloud are running on AWS. We even take that one step further by providing an AWS-optimized TensorFlow, which takes the resource utilization of stock TensorFlow from 65% to 90%. So we have a lot of customers using TensorFlow on AWS, and it's a first-class citizen in our platform. They use SageMaker to predict energy demand and improve efficiency of spot markets. So next up, we have Beth Israel Deaconess Medical Center. They are a teaching hospital. They are associated with the Harvard Medical School. They're located in Boston. Before commencing surgery, the staff need to verify the patient has completed the proper consent form. There's a lot of prereqs before a patient goes through a surgery. They want to make sure all the work is completed before they roll someone into a surgery. So essentially, they're using SageMaker to identify all the completed patient form coming from every which way, including faxes, including email, documents, whatnot. They want to make sure all the things are available before they go to a surgery, lowering the number of delayed and canceled procedures. Obviously, they have a limited set of ORs and operating rooms and surgeons on site to be able to support that surgery, so they want to be able to utilize that properly and efficiently. ChickfilA uses MXNet. This is Apache MXNet. It's an open source framework practitioners commonly use for machine learning and deep learning needs. Also supported in part of the SageMaker platform. They use MXNet. They operate more than 2,300 restaurants all over. And they use SageMaker to essentially use computer vision models to identify the freshness of fries, which is pretty important. So next up, we have Digital Globe. For those of you who don't know Digital Globe uses satellite, like WorldView 3 satellite, to capture a lot of the rich satellite imagery from lower orbit and higher orbit satellite. Essentially, they're collecting petabytes of data. So if you store all that in a storage service like S3, compared to a lower cost storage tier like Glacier or Deep Archive, they could be potentially spending a lot more money. So we worked with them to build essentially a machine learning model to build a caching layer. So they could have over 100 petabytes of data. Doesn't mean all their users will be accessing all that data at any given point. So they were able to essentially building a caching layer using machine learning based on the user demand, and they were able to increase the caching rate up to 83%. At some point, it was 90% cache hit rate, which means 90% of the time users are actually accessing the cache, not going to the lower tier storage. And rest of them, they can save a lot of money by storing that in a Glacier type storage. Next, in the education space, we have ProQuest. They work with Machine Learning Solutions Lab, and we tested different algorithms that SageMaker offers, and also their own algorithms. And they tuned the models, including hyperparameter optimization. Hyperparameter optimization that Kumar touched based on is a functionality that's available in SageMaker, essentially using machine learning to solve a machine learning problem. It uses machine learning algorithms to extract the hyperparameters that needs to be extracted from your code, from your machine learning code for better performance. So they tuned a variety of hyperparameters and did optimization to automate the deployment of machine learning models. Every year, truckers in the United States cover more than 95 billion highway miles. This is enough to go around the globe over 3.7 million times. In 2018 alone, 800 billion will be spent to move 12 trillion tons of trucks of cargo. If you look at the data, 40% of the miles that are clocked by truck drivers are done with an empty truck. So there's a huge amount of cost that can be saved here. So Convoy uses SageMaker to build and train machine learning models to optimize a variety of things like driver schedule and also the demand, and ensure load balancing and capacity price planning and all that being included, including saving cost as a result. So this is from World Bank. They use machine learning to essentially ingest the data and also use our SageMaker platform to build a machine learning model which can present sort of a data like 11% increase in accuracy for conflict-ridden countries like Somalia and South Sudan. So the way they're doing is they are, if you look at the data, 90% of the famine in the past few decades has happened in countries are affected by conflict, directly or indirectly. So by using machine learning, they can predict what are the causations that are related to famine. Last, we have GE Healthcare. Kumar touched base on that a little bit. So they use SageMaker platform GE Healthcare has pioneered X-ray technology since 1896. So since then, the X-ray machines have come a long way. So they are thinking about like how can we use machine learning to improve patient outcomes. To that extent, they are using SageMaker to deploy a machine learning model that can learn from thousands of medical images to detect anomalies more accurately and effectively. So you may be having, if this is the first time you're learning about SageMaker, or you've already used SageMaker before, or you're running some production workload, you may have a lot of questions. So I thought I will take some time to kind of recap some of the common questions that we hear from customers and provide a sort of a cheat sheet for you to have those conversations in your own organizations. And obviously, we're here anytime for you to ask if you have any questions. But let's recap on a few themes that we come across all the time from across public sector. So first off, it's security. Is SageMaker secure? Is my data secure? Is my workload secure? What are the things around security? So first of all, SageMaker runs as part of a VPC, which means your virtual private cloud, which means you have access to the data and only you have access to the data. As part of the shared security model, AWS does not have access to your data. You control the access and you have access to the data based on how you configure. Essentially through security groups. One of the code examples that Kumar showed, there is a security group example where there's a specific security group you can assign and limit those policies that way. You can do a network access control list and limit those access that way. You can do end-to-end encryption. Because it's running your VPC model, you can essentially encrypt all your data that's used by SageMaker. And also there's inter-container encryption on the back end as well. And then you can also assign fine-grained access control. This is using IAM policies that you can define specific fine-grained access on a need-only basis. SageMaker platform is built for flexibility. So there's no one-size-fits-all. In all humbleness, we don't know the number of ways you will be using SageMaker or number of ways that you are doing machine learning today. So we want to make sure that platform is so flexible as possible. There's build environment, there's train environment, there's tune and deploy. You can use parts of it. You can use combination of those. It's really up to you, depending on what you're trying to do. So our goal is to make sure we can help you iterate as fast as you want. So to that extent, you can bring your own models. You can use one of the managed algorithms that are available part of the SageMaker platform, or you can bring your own algorithms. In that case, you can package your algorithms into a container and put that in S3 and link it to SageMaker and deploy it that way as well. You can do A/B testing if you want to direct 5% of your users to a specific model that you have built and you want to use test it out, and before you roll it out to 100%, you can do so by a simple configuration. It could be in the UI, or it could be just an AWS SDK or a CLI call. And next, you can do model layering. Because we have a model and endpoint configuration separation, you can do model layering. This allows your data scientists and developers to iterate as fast as you want as they are building those models. A lot of times, if you're a practitioner, from model building to deployment and seeing inference results, it's not a straight line. There's a lot of iterations that you're doing in the middle. So along the way, you have a lot of tools to be able to go accelerate that. And the second you deploy your models, you don't have to talk to a UI developer to say, can you build a RESTful API on top of it, right? So now data scientists have, for the longest time, haven't been partaking on the DevOps revolution. That has been very common for application developers. So if you're an application developer, you check in your code, it goes through various checks and goes into production, right? So if you're a data scientist, if you were to go deploy your code, you need to build an API. A lot of times you may not have the skill set to be able to go build an API wrapper on top of it. So what do? So in this case, we built that as part of the platform. The second you deploy, you have a RESTful endpoint available, and it's highly available. You can do multi-region support, multi-AZ, and have all those taken care of. So on top of that, there's SDK available. So you can fully programmable SDK. You can just download and program on top of that. There's also Apache. If you're running Apache Spark, there's also a Spark SDK for SageMaker as well. There's a very interconnected, flexible platform. And there's also ML Marketplace. Let's say you don't want to build in the business of building models. So you want to lease models that is built as part of a marketplace. Yeah, there's a vibrant marketplace of over 200 different algorithms that you could lease for your needs, if that fits your needs. Or if you're a company looking to monetize or creating a new revenue stream, because you have built a lot of models over time, you can put that in the marketplace and other customers can use. It's a pay-as-you-go kind of model. So next thing I want to touch base on agility. You have the key thing that we built SageMaker is you have the choice of frameworks and the infrastructure. You can deploy, you can use CPU, you can use GPU, you can deploy it on the edge. All that options are available. SageMaker Neo is essentially a model compiler that Kumar mentioned. You can build it. You can build your model using SageMaker and deploy that payload into different infrastructure types or different chip types. It could be ARM, NVIDIA, or Intel, and so forth. And we also have 18 different managed algorithms that are available out of the box. These are high-performance algorithms. We manage those algorithms because we were able to make those underlying infrastructure updates to give you back better performance. So we're seeing 10 times faster performance for the same algorithms than you can find anywhere else. And our pace of acceleration is continuing to accelerate. So last year alone, across our AI/ML suite of services, we released over 200 new service features and capabilities. So we are continuing to innovate. We have a group of applied scientists, we have software engineers, we have application development teams. They're constantly bringing new features. So just by the fact that you're opening an AWS account, you have all those capabilities, which was available only to the largest of the institution or science and research organizations, to everybody to be able to take advantage of. Let's talk about open source a little bit. The common theme I hear from customers is that separate proprietary things that AWS is building as part of SageMaker, or is that open source? We leverage Apache MXNet quite a bit. It's an open source that Amazon contributes to that quite a bit, and also we use that part of our own stack. AWS optimized TensorFlow that I mentioned, it's essentially we took the TensorFlow that was available in the market and uses resources only 65%. So that's a huge waste of resources. So we challenged our resource engineers to improve that resource utilization. So that resulted in AWS optimized TensorFlow, and that can increase the resource utilization to 90%. And then we also contributed a deep graph library. So cost model for SageMaker is super straightforward. It's on-demand instances. If you search for SageMaker pricing, there's a bunch of different examples you can search for and think about the cost that goes in for your training instances. Once the training is completed, we turn off those instances. So you don't have to worry about, did I turn off my instances after I completed my training? All that things that you would take it for granted is already baked into the platform. And on top of that, you also have SageMaker ground truth service that can reduce your labeling cost. If you're sitting on a pile of data that requires a lot of human annotators, and that takes a lot of time to be able to get to a point where you can start using machine learning. So in that case, SageMaker ground truth that Kumar mentioned, where it's a fully managed labeling service that can reduce your cost up to 70%, and it has human labelers, it uses deep learning to identify who I can send those labeling jobs to. And also, there's a partners community. You can send the labeling jobs to a partner and integrate them as part of the platform as well. So you can accelerate your labeling time and go right into machine learning adoption. And second, there's also a functionality called elastic inferencing. That essentially, it's a GPU you can attach to any EC2 instances. That can reduce the cost, lower the cost over 75%. On top of that, we're also investing on the silicon, the chip itself. We launched a new product called AWS Inferentia chip that combined with elastic inference, it can result into over 10x cost savings. And finally, I want to touch base on one of the things that we didn't really go deep on this one because we're talking about SageMaker platform. On the 3 layers of the AWS machine learning stack, the topmost layer of the stack is all AWS AI services. In this case, you don't even have to build the model, train the model, or tune the model. All these powerful capabilities are available in your fingertips as a single API call. So this is for developers who are trying to build some intelligent applications. You can take advantage of that as well. So last question I hear from customers, which is a common theme, how can I upskill my employees? How can I get on top of these advanced capabilities? Why is it really that hard? How can I learn faster? How can I implement faster? So we launched Amazon Machine Learning University, and it's a free digital training, over 40 hours of training that is available for everyone to use. This is a training that we developed for our own engineers, and we have refined that over time. Now we have published it and made it available for everybody to use. So you would notice it's not just for developers. Machine learning it's past its hype cycle. It is here to stay. It is making some tangible business impact for public sector customers and enterprise customers alike. So you would notice if you're a business decision maker, you need to be asking the right questions so you can solve the right problems. You can focus your energy and your team on the right challenges. So we have courses for business decision maker, data scientist, data platform engineer, and also you can prepare for any of the AWS exams, including the machine learning specialty program or specialty certification. 5 things for you to take home with. We talked about products a lot. As practitioners or as engineers, we're all super excited about technologies. We're super excited about capabilities and how we can use it. But I'm suggesting you to fight that instinct and take a step back from the technology and think about what are you trying to solve. Identify the business problem that you're trying to solve, and be clear about the outcomes. What are you trying to get a result? What are the outcomes you're trying to get a result by using that? Maybe ML is an answer, maybe it's not. But don't start from the technology first approach. Think about what is the business use case, what is the customer-centric perspective that you have. That's how we build products across Amazon, and that's the discipline we can provide that to you. So identify the business problem that you're trying to solve. Be clear about the outcomes. Next is data. Think big, test small. So have a really big vision on what you want to do, and think big by all means, and choose a small, well-understood data set that you are trying to experiment without boiling the ocean. If you have a data set spread across multiple different data silos, you can build this beautiful data lake that ingesting data from all the different silos, and that's going to take forever. Then instead of data sitting in 5 different places, now it's sitting in one place. Still, it's not going to get you where you want to go. So be specific and explicit about what you want to accomplish. At the same time, choose a small data set that is really well understood, and try to see how you can get faster to those outcomes. So we have a saying in AWS, if you reduce the cost of experiments, innovation happens. At Amazon, we have this fail fast mentality. So what that really means is, how can we reduce the cost of failure? How can we reduce the cost of experiments? Jeff Bezos talks about, we have billions of dollars of failures, and what is that thing? What are those things that what are we learning from that? So by failing fast, by reducing the cost of experiments, there's nothing stopping you from building a small prototype, building a small workflow, and ask help when you can. And so you can see if that really works for you. Involve us in part of the design process. So I'll have my email here. I'll put Kumar's email here. Shoot us a note. If you're working on a problem, try to solve that on your own for a little bit. We have a lot of documentation and public information that we already have. You have a specific question, definitely send us a note. We're happy to talk to you. And start building. This is where you can read a lot of documentation. You can read a lot about theses and white papers around machine learning and artificial intelligence, how it's impacting, a lot of case studies. But start doing something small and sort of iterate from that success. Thank you for your time. We'll be here for any questions.